Good afternoon, everyone. So today, since we were doing some unit conversions, mainly focusing on dimensional analysis in the Math 154 course, we're going to do the same thing in the MDE course. So focusing on stuff from 3.1, converting things from like minutes to days, et cetera, et cetera. Now, again, I am going to do pretty much everything the dimensional analysis way, just because we haven't had nearly as much practice as using proportions. However, anything that can be done with dimensional analysis could also be done with a proportion. So if you prefer to do things that way, it's never going to harm you in the Math 154 course. Again, those are interchangeable methods. You just have to make sure you have a method down. There will be at least one example today where I will do it with dimensional analysis, and then I'll do it as a proportion to show you that this is true. But again, if at the end of the week, at the end of the month, you just really dislike dimensional analysis, make sure that you understand how to do it with proportions instead. But dimensional analysis is a lot easier than a lot of people let it on to be after you practice it. But just like with many things in life, you have to practice it or else it's not going to make sense. So what we're going to do today is I'm going to do several examples on my own, and then I think I'm going to do them in pairs. I'm going to give two examples, and I'm just going to let y'all work quietly on your own. And after about 5 or 6 minutes, then I will come back and I will cover how to do them. So it's going to be a little bit of a mixture today. We'll have some examples that I do personally. Then we'll have some examples that I'll just put the problem up on the screen. I'll stop talking for, again, 5 or 6 minutes while y'all work quietly on your own and try to get your own answers. And then again, after those 5 or 6 minutes, we'll cover them and you can compare and see how you did. So with that being said, let's go ahead and dive into things. Here we go.
Now, I will be doing my problems for the most part the dimensional analysis way. I'll do at least one of them as a proportion so you can see that I don't care which way you get it done as long as you can get it done. So remember that dimensional analysis my kind of core idea is out with the old, with the new. That's the way I like to say this. That's just a mnemonic device, I guess. It's not a word, it's a sentence that just helps me, and I feel like it helps a lot of people remember how to handle this. Now, this doesn't say that, okay, well, your old units are in the top, so put them in the bottom of the multiplier. If they were in the bottom, put them in the top of the multiplier. But it's just a clue as to what's going on, what needs to be done. You got to get rid of the old units before you even start looking at numbers and everything. You can just go ahead and set up that multiplier with your old units in the opposite position so that they will cancel. But that's the important thing. If you don't put them in the opposite position, they won't cancel. If you put numbers in wrong places, things will get goofy from there. And we said that your alternate way is to use proportions. Make sure you use your words first. You've got to use your words first. Write apples over oranges, write students over teachers, write tags over binders. I mean, whatever the two things are that you're talking about, that way you know which one goes in the top and which one goes in the bottom. Otherwise, you'll start flip-flopping things and it'll be wrong, 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 wrong. All right, so examples. And if you haven't watched that main lecture yet, I would highly advise you watch it immediately. So for number 1, we're going to convert 82 feet to meters. Oops. I could have typed that part out. In fact, I will. Why not? Example 1, convert 82 feet to meters. In fact, at 3.281 equal to 1 meter. So I'm giving you the conversion factor right inside of the example. Let's take away the parentheses part. Stop doing that. we go. So we're going to convert 82 feet to meters using the fact that 3.281 feet is 1 meter. So I've given you the conversion factor again in your homework problems. If you just hit the view an example or help me solve this, you can find those as well. Otherwise, you go to Google. Otherwise, you go to your textbook. Remember, Google sometimes is, if you were supposed to have done this with like 3 conversion factors along the way, Google won't make you do it that way. So I'm not saying that Google is your go-to, but again, I know that when this course is done, that's probably what you're going to be doing. And it is ultimately fine, but you still need to practice with the multiple steps. All right, so what do? First thing we do is we write down the original value. Now, I don't just write 82. If I just write 82 and then start writing a fraction, that would be bad. That would be bad because your units are the absolute most critical component of this process. If you don't put the units, you don't know how to proceed. So, 82, do I multiply by the 3.281 over 1? Or do I need to flip-flop these? I don't know because I'm not using my units. I don't know where to put things. So take your time, pay attention, and write the units. I know you don't want to write the units. I know you don't, but you got to. 82 feet. All right, so then we multiply by a fraction. That's dimensional analysis. What goes in this fraction? Out with the old, in with the new. The feet are the units that need to go away. That will out with the old them because the feet were in the top and the multiplier, they need to go in the bottom. And then we just put the numbers in place for this. So the meter would go in the top, M is for meter, and it takes 3.281 of those meters to make a foot, right? Inflection and voice? No, it's 3.281 feet. That's where the 3.281 has to go, and the 1 has to go with the meter. After you write this, go back and look. Hey, the 1 meter, that's right. The 3.281 feet, yep, that's right. We're good. Okay. So the feet are going to cancel, and then we can just pull out our handy-dandy calculator, and we'll take the 82. And we do not multiply, we're going to divide because the 3.281 is in the bottom. So we divide by 3.281. We hit enter, and we're going to round these to the nearest tenth. So that's 24.99. But rounding to the nearest tenth, the 9 in the hundredths place tells us to round up, which says the 9 in the tenths actually rounds up to a 10, but you can't put 10 in a single digit, so the 1 goes over to where the 4 is, and it actually becomes 25. And if you box this up, that's wrong. The answer is not 25. That is completely and horribly wrong. Now, in my math lab, it's all you'll have to type probably, but we're quantitative students, and we know that numbers have units. We were converting to meters, and that's the only unit left in there. That's exactly what we wanted to see. So 82 feet is equivalent to 25 meters. An alternative way to have done this, and this is the only one I'm going to do using proportions. The alternate way is using proportions, but make sure you use your words first. So what are the two things we're talking about? Feet and meters. So I'm going to put feet in top and meters in the bottom. If I want to do them upside down, nobody's going to care. It would just mean that then I put all the meter numbers in the top and all the feet numbers in the bottom. I'm choosing to do feet numbers in the top and meter numbers in the bottom. And when you write proportions, you don't put the units in here. You can, but it's going to make the algebra wonkier, wackier. So nobody does it with proportions, but you better with dimensional analysis. That is how dimensional analysis rolls. It doesn't work without them. All right, so one of these sides has to be the conversion equation, the fact that 3.281 feet is 1 meter. It doesn't matter if it's left or right side. So can I put the 3.281 in the bottom? Well, since I said meters go in the bottom, no, I can't. I have to put the 3.281 in the top to signify that it is a foot or in feet. Then the 1 meter is what goes in the bottom. You have to put those paired together. I can't put the 1 on the opposite side. The conversion has to be one side, and then the number you have, the 82 feet, needs to be on the other side. But we'll just put it here, right? Nope, because that's in the meter spot. Pay attention. It has to go in the top because it's a feet. We don't know the meters for that conversion, so there's our x, cross multiply. And we get 3.281x is equal to 82. Then you'll have to divide. This is a little algebra that we've done over and over and over already. And when you do that division, it's literally going to be the exact same division we did up there. It's the 24.99, but rounded to the nearest tenth, makes it 25. And if you box this up, in my opinion, it's wrong because you did not put the units. See, the units with proportions, they're not going to be just sitting in the placeholders. You have to know, hey, where was X? X was in the bottom. Since X was in the bottom, it makes it a meter. So that's 25 meters. You can even make a proportion table out of this if you have to absolutely do that. That is perfectly fine. And we'll get you your answer. You'd literally end up making the same proportion, so I'm not going to show that. So there is our first example. Example 2. We are going to convert, sorry, I got a few written down here. These are actually page 120 and 121 from your guided worksheets, just as an FYI. We're going to do all 5 of those, or I'm going to do all 5 of those. Convert 3 days. Now, I'm not going to say using the fact that blah, 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 because I've already illustrated for my quantitative reasoning students, I expect them to memorize everything having to do with time, that 365 days is a year, that there's 24 hours in a day, there's 60 minutes to an hour, there's 60 seconds to a minute. I did say don't use the fact that 12 months is a year for these when you're supposed to be going to lower and lower and lower conversions. Now, if it's just converting years to months, yes, absolutely 12 months to a year. But if you're supposed to go from years to days or minutes or seconds or anything like that, we don't know how many months to how many days as an exact conversion because it's either 30 or 31 or 28 or 29. It's not just a single number, so it doesn't work that way. So again, you have to be careful when you're talking about months. Don't use months to go in between years and something smaller. Only if you're going between years and months. That's the only time to use months. So we will not be using months here. So again, you should know, you have to know, that's an exclamation mark. So you really got to know that, well, how many days are there? Well, we're going to minutes. So if we said, well, there's 365 days in a year, that would not be helpful for us because that's going to a larger unit of time, going from days to years when we're supposed to be going to a smaller unit of time, the minutes. So we got to make sure we're working towards the right direction. So, all right, one day, heading towards minutes, we should go to hours, and that would be 24 hours. And then how many hours to how many minutes? Well, 1 hour is equivalent to 60 minutes. You can use colons, you can use equals, nobody cares. I'm just going to be consistent and make them both equals. So those are the 2 that we'll need here. So what do? We write the starting value, and then we just multiply by a fraction, right? Nope. Write the starting value with its units, then multiply by a fraction. Out with the old, in with the new. What's the old? Days. Days is the old. And we definitely are getting rid of the days. So days are going to go in the bottom. In with the new, well, we can't just go straight to minutes because we know 1 hour is 60 minutes. These are days, not hours. So we've got to middleman this. We got to go 1 day is 24 hours. 1 day, so the ones in the bottom, is 24 hours. That'll go on the top. Now, if you want, you can go ahead and say equals and do the math here, but I don't like doing it that way. I prefer to go ahead and set up all my fractions in one go. So times. The days are not now gone. Sorry about that. It doesn't look like someone dropping off a package. I'm sorry for this. Go ahead and try and continue this one if you can. I got to make sure that isn't important. We're good. It actually was a package. I just walked through my grass, I guess. No big deal. All right. All right, so now we're going between hours and minutes. Hours to minutes. 1 hour is 60 minutes. Out with the old. The old is the hours. That was in a top, which means it needs to go in a bottom so that we can cancel them. Now that we know those will cancel, let's fill out the rest of the details here. Again, That's the first thing you should always write, the out with the old idea. Your old may be going in the top here if it was originally in the bottom. Remember to be careful and pay attention. All right, so how many hours? 1 hour is how many minutes? 60 minutes. So then the hours cancel. The only units we're left over with are the minutes, which is exactly what we need. So as long as we are careful, everything should be okay. We just got to do 3. The 24 is in the top, so times. The 60 is in the top, so times. So 3 times 24 times 60. 3 times 24 times 60. 4320. 4320. And then how do I know what the answer of the units are, the units for the answer? Well, the only thing we were left with was minutes. Excuse me. There we go. 4,320 minutes. All right, let's do another. As I said, I'm not going to keep doing the alternate way for all these problems. If you just strongly dislike dimensional analysis, if you always want to do proportions, I know I'm a broken record, but do it. I don't care how you get it done as long as you can get it done. If you are just an absolute genius with numbers for some reason and you're in this class and you can play with all this in your head and always get it right, I'm okay with that. It's not the way I'm teaching things to be done because I don't expect to have students that are brilliant with numbers in here, and I don't mean that as any offensive thing. It's just expectations. But I mean, some people are just naturally good with numbers and don't need to show some of this work. But the problem is most of the people that are naturally good with numbers and don't need to show their work still end up making mistakes when they don't. I'm pretty good with numbers, and when I don't write my units, I end up making a mistake here and there. Not super frequently, but I definitely make mistakes. All right, example 3, convert $250, I think it was. That's not a dollar symbol. This is a dollar symbol. 250 to Russian rubles. That's their currency, using the fact that 20 US dollars is equivalent to 1340 rubles. So again, would not expect you to memorize that. This conversion is probably not exactly true anymore because this problem was published a few years ago and currencies change every day, in fact. Usually not significantly day to day, but they do change every day. All right, so let's write the original number, $250. Now, I will write this one out twice because some people won't like using the dollar symbol, but I'll still write it out twice. So we got $250, and then we're going to multiply by a fraction to out with the old and with the new. So you might be thinking, well, where's your units? My unit is actually in front of the number now. It's kind of atypical. Currency is pretty much the only one that we do it that way, but that is the unit. So the old is the dollars, which means the dollars need to go in the bottom. And we said that 20, well, let me go ahead and again, a dollar symbol, if you're going to put it that way in the original one, let's do it that way in the bottom one. So that'll cancel the dollars. And it was specifically 20 of these US dollars is the same as 1,340 rubles, R-U-B. I don't know the symbol for that if there is one, and that's okay. All right, so we're going to take the 250. Now, there are numbers that aren't one in the top and bottom, so this is going to be a multiply and a divide. We're going to have to multiply the 250 by the 1340, then we divide it by the 20. So we take sorry, that's not the right number, 250 times the 1340 divided by the 20. And we end up with 16,750. Now the dollars, there's a dollar in the top and a dollar in the bottom, so they cancel, meaning that the answer is in these rubles. So that would be the answer. The alternative way to have written this, instead of writing the dollar symbol, you could use that abbreviation USD. So 250 United States dollars, and then you multiply by a fraction. Well, we know out with the old, the US dollar's got to go away, so the US dollar goes here, and it's 20 of those American dollars to get 1340 of the rubles. And You'll see the US dollars cancel, you'll be stuck with rubles, and you still get the 16,750. The arithmetic does not change. Same answer. But if you said this was $16,750, that would be incorrect. Okay, do another. Convert 120 pounds to kilograms. The fact that 2.2 pounds is equivalent to 1 kilogram. Now, 2.2 pounds is 1 kilogram. That's also the same as saying, and it's roughly 0.45 kilograms is 1 pound. That would be another conversion that you could still use and get the answer to be the same. You know, maybe off by like a tenth or a hundredth or a thousandth, as we discussed in the regular class. But I'm only giving you one of them, so this is the one I want us to use. But again, if we were looking at a table of information like in the last class, you would be presented with both of those, and you can't let that scare you. You can't go, which one do I use? Because it absolutely doesn't matter if you got a calculator on hand. I said the only time it ever matters is if you don't have a calculator and you're doing this by hand, you would pick the one that makes you end up doing a multiplication instead of a division, because that's an easier process. But again, I expect all of you are going to have calculators 100% of the time. So 120 pounds. Now, just be consistent. It doesn't technically matter if I write the word pounds in one place and the symbol LBS in another, but I just want to be consistent. So I'm going to go with 120 LBS. LBS. So there's my original value with its units. Multiply by a fraction. Out with the old. The old's the pounds. By pounds. And with the new, kilograms. And we know exactly how many pounds to how many kilograms. It's 1 kilogram, so the one goes where? Where is it? Oh, it's the top. This is what you would be talking yourself through. Then the 2.2 pounds, yep, 2.2 pounds. Everything looks good. Pounds top, pounds bottom cancel. Tops don't cancel with tops. Bottoms don't cancel with bottoms. So 120 divided by 2.2, since that's in the bottom. 120 divided by 2.2. And we get 54.54 when we round to the nearest hundredth. 54.55 actually when we round to the nearest hundredth. Had I been rounding to the nearest tenth? I've been rounding to the nearest tenth, so let's be consistent. That's why that threw me off. So if I round to the nearest tenth, the 4 says to round down, so the 5 says a 5. If I had been rounding to the nearest hundredth, this 5 would say to round up. And I'm going to say this again. You have got to make sure your rounding skills are on par. You don't want a rounding error to make you miss a problem, especially on a test. And I see it all the time. So it's 54.5 is what it was, right? Yeah. And then kilograms, because that's the only units we're left with. And that's it. Do uno mas together, or I just give you some in the 5 minutes, like I said. Example 5, convert 40 liters to fluid ounces. The facts, notice that's plural, that 1,000 milliliters is equivalent to 1 liter, and 29.57 milliliters is equivalent to 1 fluid ounce. I think I've mentioned this before, but a fluid ounce is not an ounce. An ounce is a measure of weight. A fluid ounce is a measure of volume. There is only one absolute substance where 1 fluid ounce is the same as 1 ounce, and that's water. Because the density, something we'll talk about in 3.4, is a 1-to-1 ratio. Which is just, we'll get in that later. I don't want to throw too much at you. So an ounce is not a fluid ounce. So if you write this answer as ounces, if the answer would say 13, if you wrote 13 ounces, that would actually be wrong. And I know that you dislike that because in the world, everyone says ounces. but we are being very careful and very meticulous with our units, and we don't want to confuse ourselves because an ounce of maple syrup is not a fluid ounce of maple syrup. A fluid ounce of maple syrup probably weighs, if I had, it would depend on if it's sugar-free or if it's regular. It would depend on if this is just some basic store brand or you're paying $50 for 500 milliliters of the stuff because it's super quality Vermont barrel-aged maple syrup flown in yesterday or something like that. So usually more expensive means more viscous, which means denser, which means heavier. So sugar-free maple syrup, 1 fluid ounce might be like 1.3 ounces, whereas a nice heavy sugar special maple syrup, 1 fluid ounce might be like 1.5 ounces. And again, I'm just spitballing these numbers off the top of my head. I don't have maple syrup viscosity numbers in front of me. It's not math I do on the regular, believe it or not. I'm not that evil and twisted. But now I want pancakes. Okay. So I gave you 2 conversion factors, so that's a good clue that you're going to have to do 2 of these fractions or 2 proportions or 2 somethings, right? What do? We start with the base number. We start with the 29.57 milliliters. And again, real world or homework problem, I'm not just going to give you these 2 things. You might have a table of stuff and you got to pick out which ones to use. You got to find at least one that has your starting units, at least one that has your ending units. And then from those, you can sew together some middlemen. They're like, all right, I see one that's got milliliters. I see one that's got fluid ounces, but both of them have liters in common or something like that. Or we're starting in liters here yet. So I see one that has liters. I see one that has fluid ounces, and both of them have milliliters in common. So there's my link. There's my middleman, so to say. All right, so multiply by a fraction so that we're out with the old. That was a way too big of a division bar. Did not need it that big. Milliliters, out with the old. Now we can't go from milliliters to why did I write milliliters? Why did I write milliliters? Because I was thinking and writing and talking at 3 different speeds. I was not supposed to write milliliters, I was supposed to write liters. So let's rewind a little bit, but this is how I realized that I was about to make a mistake. I went back and saw the example. So not 29.57 milliliters, that's not even the number, is it? I was just looking at this and, oh, that's our number. No, that was me not paying attention because I'm doing too much at once. And again, I love making those simple little mistakes unintentionally. I make lots of intentional mistakes, but I also love the unintentional ones because it shows you the thought processes that you should be going through, the checking along the way. Convert 40 liters. So that's what we're starting with. And I'll do L for liters. Now multiply by a fraction, out with the old. So liters goes in the bottom. Now we know we're setting things up better. All right, liters. Well, this one doesn't have liters anywhere, so we're not using this yet. It will get used, just not yet. This one has liters in it, so it's a good candidate for first use. Going from liters to milliliters. So milliliters go on the top. How many liters to how many milliliters? Let's take our time. 1 liter is 1,000 milliliters. Out with the old. The liters are gone. But now we're in milliliters, which is not the units they want, which means we got to do this again. So times. Out with the old. What's the old? It's the milliliters. So we put milliliters in the bottom. The old is not always the original one. It's whatever we just most recently have. In with the new. What can we go from between milliliters? Well, this is milliliters to liters, but if we use that one, we're going back to what we originally had in liters. So don't use that one. We already used it, so we probably don't use it again unless it had, you know, inches squared, feet squared, which we'll do another example of later. We're using this one. The 29.57 milliliters is 1 fluid ounce. So 29.57 milliliters is 1 floz. Flosberries taste like flosberries. Yes, I know I'm weird. All right, out with the old, the milliliters cancel. The only thing we're stuck with is the flozes, the fluid ounces, which is exactly what we're supposed to convert to. So we'll take the 40 times the 1,000 because that's in a top, but we will not multiply the 29.57 because it's in a bottom, so we divide it. So we take our 40 times the 1,000. Some people might have just known to move the decimal right 3 places as well to convert it to milliliters. That's fine as well. Then you divide this by 29.57. And we get 1352 and some change. We're going to round to the nearest tenth. So the hundredths is a 2. That tells us to round down. The 7 stays a 7. So 1352.7. What are our units? The things that weren't canceled, flosses. And remember, you will be seeing this stuff done with rates, things like miles per hour, like that one we did in the lecture. So it's not always just one unit in the answer, it could be 2. When you get into crazier math, there can be 3 or 4 or 5 units. You could have like like pounds per meter square or meter square per pounds. One of those, and I'm not going to say which, relates to density. All right, so those 5 examples, again, were on pages 120 and 121 of your guided worksheets. So you see exactly what those are. I'm going to do another example, though, that is not on your guided worksheet anywhere. And what I want to do is convert, this one's going to be a little longer. Let's go with town speed, 35 miles per hour to feet per second. The fact that 1 foot is equivalent to 12 inches. We're going to convert 35 miles per hour to feet per second. A lot of physicists and engineers like the measurement of feet per second because it's a much smaller distance and time scale. And just sometimes we want to be talking about that. You know, it's nice to think about things in miles per hour because it's something we relate to constantly, especially with driving and walking. Driving speed probably average 55 on the highway, 35 around town if we're doing speed limits. Walking speed, 3 miles an hour, running speed, maybe 5 to 6 miles an hour for your average runner, 8 or 9 miles an hour for someone that's awesome, 12 miles an hour for your Olympians, biking closer to 20 miles per hour. So these are tangible numbers. If I were to ask you any of those in feet per second, you'd probably scratch your head and go, I don't know. But this is how you could find out. You could just do this type of conversion. So miles per hour to feet per second. Now, I only gave you the feet to 12 inches, just like I would do on a test or a quiz even. So how do you know, how do we go from hours to seconds? So let's just go, you also need, but again, this would be off of memory. You got to go from hours to seconds. So 1 hour would be 60 minutes. That's getting closer to seconds, but not exactly the same. And then we'd also need to know that 1 minute is equal to 60 seconds. There is no excuse not to know those. All right, so let's start with 35 mph, miles per hour. Now I'm about to write this wrong. I'm gonna pull red out temporarily. You can't do it this way because this doesn't show where the miles and the hours are specifically. This won't get the cancellation going properly. So don't do that. You've got to write these units in fraction form. Miles per hour. Per means the next thing goes in the bottom. So this is MI over hour. That is miles per hour. Multiply by a fraction. Out with the old, in with the new. Now the question is, what are we trying to get rid of? Well, we're trying to get rid of the miles because the miles need to turn into feet. The miles have got to convert to feet. Then, or it doesn't matter which order you do it. So in addition, we've got to convert hours to seconds. Our distance conversion is going from miles to feet. Our time conversion is going from hours to second. So we're going to have to account for both of those aspects. The cool thing is it doesn't matter the order we do it. This is where I'd ask if anyone has an opinion, but I'm just going to go ahead and do the miles first. So let's go. And, oh, I forgot to write another one. I said 1 foot is, why did I write 1 foot is 12 inches? I was supposed to do miles and feet. Silly me. Then 5280 feet. is equal to 1 mile. Sorry about that. It is also important that 1 foot's 12 inches. It's just irrelevant for this problem. So this would go from miles to feet. 5280 feet is 1 mile. So I'm trying to eliminate the miles currently. I'm not going to think about the hours for now. The hours aren't even here. Ignore them for just a minute. And don't scratch them out. Just pretend they're not there. I'm focusing on the miles. Out with the old, out with the miles. So if the miles are originally in the top, in the multiplier, let's go back to red. Red miles go in the bottom. Now we'll use the fact that 1 mile is 5280 feet. So 1 mile is 5280 feet. And again, you could go ahead and process the arithmetic here. It's not important. Just show the canceling. Miles are gone. That was a bad one. So converting from miles per hour to feet per second. Well, now we have feet. That's exactly what we need for one of the units. So we don't need to convert to inches or to kilometers or anything goofier. We now have the unit of distance we need. But we're not done. While we have the distance accounted for, the time is wrong. Our hours need to be turned into seconds. So we need a multiplier for that. Out with the old. What's the old now? Hours is the old. Where are the hours? They're in the bottom. So in the multiplier, they go where? In the top. All right, well, how many hours to how many seconds? I don't have that, again, well, you might not have that memorized off the top of your head. It is 3,600 seconds for 1 hour, but let's do the middleman stuff. 1 hour is 60 minutes. So the miles were gone because we had 1 in the top and 1 in the bottom. The hours are gone because we have 1 in the bottom over here and 1 in the top over here. As long as it's all a product, doesn't matter if they're not sitting next to each other, they still cancel. But we're now in minutes. Is that what we wanted? No, we wanted seconds. So we got to get rid of the minutes. Nobody said these were always short problems. So let's go to orange for our next multiplier. So out with the old, minutes are the old, minutes are in the bottom. So in our multiplier, they go in the top. How many minutes to how many seconds? 1 minute to 60 seconds. Sorry, I should have had water. I'll get that while I set y'all up with some problems. So out with the old, the minutes cancel, top and bottom, show your work. Without canceling and showing your work, you might not know things cancel. All right, so now we can finally do some math. We have the 35 times the 5280. The 60 is in the bottom, so we'll divide it. The next 60 is in the bottom, so we'll divide that as well. Let's get our calculator. Let me do this. No, bad technology. There we go. Starting with our 35 from the miles per hour times the 5280 divided by the 60 divided by the 60. And then there was 1. And we end up with 51.3 when we round to the nearest tenth. So 51.3, and if you box this up, you know it's wrong. You know it's wrong. Why is it wrong? Because you didn't write your units. What are the units we're left with? All right, the miles, the hours, the minutes, the second, they're all, well, I said seconds, but I didn't mean to say them. The hours are gone, the miles are gone, the minutes are gone. We're left with feet in the top and seconds in the bottom. So this would be feet over second, also known as 51.3 FPS, not frames per second, feet per second. Some people might even go FT per second. But both of those are accurate answers. Again, F for feet here, not frames. Not talking about a refresh rate on a piece of technology. So 35 miles an hour is 51.3 feet per second. Now here's something cool you can do. Maybe your job has you converting miles per hour to feet per second over and 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 over. And you go, I don't want to have to multiply by these 3 fractions over and over and over, or I don't want to set up 3 proportions over and over and over. What you can do is, now that you have a starting point and an ending point, you can just divide them, and that gives you a multiplier. So you take your answer of 51.3, and technically you should use the 0.33333333, but this is good enough. and divide it by the 35. And what this says is for every 1 mile per hour, it's 1.5 roughly, or 1.47 feet per second. Every 1 mile per hour is 1.47 feet per second. So if I said, all right, we're going 60 miles an hour, you could just take 60 times your 1.47. So if you're going 60 miles per hour, that's equivalent to going 88.2 feet per second. If you're going 10 miles an hour, take the 10 times the 1.47, and it's 14.7. What I did there with dividing the 51.3 and the 35, that gives us the direct conversion from miles per hour to feet per second as a multiplier. That's exactly how these dimensional ratios are created. You take a known value in one, a known value in the other, divide them, and there's your conversion factor. That's all it is. The order you divide them tells you the order you're going one to the other, whether it's 1 mile per hour is this many feet per second. If I had done 35 divided by 51.3 instead, if I flip-flopped it, this would be going from feet per second to miles per hour. So if I knew something was, say, 60 feet per second, if I multiplied it by that, it would convert to miles per hour. So you can create your own conversions. So if you had to say a problem where you multiplied by 2,000 fractions to get it done, and your boss said, you've got 100,000 more of these to do, you're going to say, I don't want to do those multiplications anymore, all those multiplications. I'm going to take the last one, divide it by the first one, and boom, there's my multiplier for a y equals kx setup. It gives you efficiency. It gives you the ability to finish your job in a very short amount of time by putting this stuff in Excel and auto-filling formulas. And your boss is happy because you get the job done early, and you get a new bonus, and whatever else. The rainbows are out, all sorts of happy things. All right, so we got about 30 minutes left. I actually lied. I want to do one more problem. I want to make sure I'm doing a good variety of these. And I'm ultimately going to end up doing the ones I give you time on anyways, so I don't know. I hate just having dead air, but I will do that after this. This is the last one, I promise. Convert. Let's go with 45,000 square inches to square feet. Using the fact that 1 foot is equal to 12 inches. I did not give you the conversion from square to square feet and inches. You have to do what I talked about in the last lecture. You can either square both sides of that conversion factor, which tells you that 1 square foot is 144 square inches, or you just have to multiply by that conversion factor twice. I find most people do the second thing I said, so that's how I'm going to do it. So let's start with the 45,000. Now, square inches, when you're doing it this way, you have to write it like this. Then we will multiply by a fraction with the old and with the new. The old is the inches, so they're in the top originally, so some inches got to go in the bottom. And we know that 12 inches is 1 foot. 1 foot, 12 inches, 1 foot, 12 inches. This cancellation, though, this single inch unit here will only cancel with one of the inches. It doesn't cancel both of them, just one. So now that's in inches to the first power, which says we just got to do the same thing again. Multiply by 1 feet over 12 inches. Out with the old. Now all of the inches are gone, and the feet don't cancel out. They stack because they're both in the top. Feet times feet is feet squared. So our units in the answer will be feet squared. Actually, let me write the number first because it'll be a big-ish number. So we're going to take 45,000. If I multiply by 12, that would be wrong because those 12s are in the bottom. So divide by 12, then divide by 12 again. And it gives us 312.5 feet, so feet squared, or you can write it as 312.5 square feet. Same thing. Again, in my math lab, most of the time you don't even have to write the units, which I strongly dislike about my math lab for a quantitative reasoning course. Half of the purpose of this is making sure you're using your units everywhere. So I really wish I could get them to have a slightly different format and make it a little less easy. But I can't control it. All right, so for y'all, Try question mark? No, try. For number one, let's convert, and let's do time one. I really wish it didn't do that. Oh well, I'm not going to fight Word over this. Convert 16 hours to minutes. And then for number two, convert let's go with 20 cups fluid ounces. The fact that 8 fluid ounces is equivalent to 1 cup. There's a whole boatload of volume conversions. 8 fluid ounces is a cup, 2 cups is a pint, 2 pints is a quart, 4 quarts is a gallon. If you play around with those numbers, it also means that 32 ounces, fluid ounces is 1 quart. It also says that 2 cups is a quart. It also says that 16 ounces is a pint, 32 fluid ounces is a quart, 128 fluid ounces is a gallon. But you don't have to memorize every single one of those things. You can just chain them. All right, so I'm going to shut up for about 5 minutes and let y'all try those out. And then I'll come back and I will see, I'll show it and you can find out if you got it right or wrong. All right. So converting 16 hours to minutes. So we start with our 16 hours. And how many minutes to how many hours? Well, 1 hour is 60 minutes. So again, I did not give you this, but you should know that 1 hour is 60 minutes. So we're going to multiply by a fraction. Out with the old, the hours of the old, they were in the top, so they go in the bottom. So that way they'll cancel. And it's one of these hours makes 60 minutes. Hours are gone. We'll be left with minutes for whatever the answer is. And we're just going to take the 16 times the 60. Which will give us 960 minutes. There we go. That's it. Number 2, convert 20 cups to fluid ounces using the fact that 8 fluid ounces is 1 cup. So we write our original number, the 20, not just the 20, the units as well, 20 cups. Then we're going to multiply by a fraction. Out with the old, so cups go in the bottom, in with the new, and we have something going between cups and fluid ounces. Clauses. And then we put the 8 in the bottom and the 1 in the top, right? Question mark. No. 8 cups is not 1 fluid ounce, it's vice versa. 8 fluid ounces is 1 cup. Pay attention, be careful. Nobody's perfect, but as you check yourself, you can catch little mistakes. So that's just going to be 20 times 8. 2 times 8 is 16. Tack on the 0, so that's 160. Not going to show that in a calculator. The cups cancel, and we're stuck in flazes. Now, 128 fluid ounces is a gallon. So this is just a little more than a gallon. It's 32 ounces more than a gallon, in fact, which would be a quart. So it's a gallon and a quart. Is that information that you absolutely need? No, but it might help you have a better understanding of the amount of volume of something. That's one of the main reasons we have unit conversions, because sometimes a number in a unit might not make sense to us, but by converting it to something we have more experience with, maybe it makes more sense. Or maybe it's 2 different people or 2 different companies dealing with numbers and units. One company is dealing with metric and the other is dealing with SI, and somebody's got to convert to be able to compare your stuff. All right, let's do 2 more. Convert. What did I want to do for this one? It was 11. It wasn't miles. It was 11 inches to centimeters. The fact that 1 inch is equal to 2.54 centimeters. 3, 4. We're going to convert 0.0002 years to seconds. And I'm not giving you any facts for that one. So 4 is obviously going to be a little longer. We've seen examples like it, but I'll give you your, let's call it 7 minutes, 6 minutes, 6 minutes. That'll probably be the last 2 we do. All right, so 11 inches, and we multiply by our fraction. Out with the old, so inches go on the bottom because they were in the top. In with the new, centimeters, and put the numbers. 1 inch is 2.54 centimeters. Cancel. 11 times 2.54. We get 27.94, and that would be in centimeters since that was the unit left. And there we go. All right, last one. Now, 0.000123, good, just making sure, 2 years. So that's tenths, hundredths, thousandths, 10,000ths. That's 2/10,000th of a year, or 1/5000th of a year. It's a very small amount of time. How small? You probably have a hard time considering it, but it's small in relative to a year. So maybe it would be better to think about it in minutes or seconds. So let's see what we get. Multiply by something that takes us from years closer to seconds. So out with the old, years go in the bottom. In with the new, we can't use months if we're trying to get to seconds. That's the only issue with time. We got to go to days. And it's 365 days to 1 year. Years are now gone. Next, we got to get rid of days. So out with the old. Days are in the top, so let's put them in the bottom so they cancel. Days to something closer to seconds. Well, how about days to hours? And it's 24 hours to 1 day. Days are gone. Let's do another multiplier. Hours, we can go to minutes. Out with the old, so hours go in the bottom. Minutes then go in the top. It's 1 hour is 60 minutes. And then one last one. Oh, sorry, I forgot to cancel, but that's okay. The hours will cancel. And then going from minutes to seconds, out with the old, minutes go in the bottom, in with the new, seconds in the top. 1 minute is 60 seconds. Minutes are gone. And we're just going to take the 0.0002 times the 365. So now we're in days. So you can even do this like one step at a time. So 0.0002 years is 0.073 days. Multiply by 24. That says 0.0002 years is 1.752 hours. Multiply by 60, and it'll be in minutes. So it's 105 minutes. Or if you multiply by 60 again, that'll get you to seconds. And it's 6,307.2 seconds. 6,000. I want to write that just a little better. The seconds kind of got squished in. 6,307.2 seconds. So which of those numbers sounds the most favorable? I mean, 6,000 seconds might be kind of hard for some people to understand. You know, like how long what could you do in that time? Would that be a small amount of exercise for you? Is that a TV show? Is that study time? So I'd say the most favorable unit out of all these numbers is probably the 105 minutes, or even the 1.75 hours. Those two were pretty good and tangible. Oh, 1.75 hours, that's about a movie. 105 minutes, again, also about a movie or about a class time usually. A little closer to 75 minutes for a class.
And speaking of that, that is where we're going to end it for the day. So we had a decent amount of examples with these. Hopefully you liked having the extra little time to try and work on these on your own. As I said, I'm going to try and do this occasionally, maybe not every class, maybe every other class. I'm not going to say exactly how often, but I am going to try and do this a little more to give you time to work at the same time during class, not just follow along or have to use the replay to give yourself time to work on these. All right, so we'll pick up where we left off. Next time, we'll start trying to do some stuff from 3.2, whatever that is. We'll find out in Math 154 next time, of course. Maybe it has to do with scales, hint, wink, nudge. But yeah, hopefully this was informative and helpful. As always, keep up with your homework in both Math 154 and MDE 54. Some of you that were kind of skirting the line on the assignments did a good job keeping up or catching up, but don't just do that once. You're going to have to keep up the rest of the semester. That whole withdrawal thing can happen at any point if you stop doing your homework for several weeks. All right, so have a good one. Email me with any questions, and we'll see you next time.